Well, welcome to this online revision session for AQA FP2. In this session we will be considering the January 2010 question 8, which is on the topic of the Moivres theorem. So we've got three parts to this question. First part is to do with the roots of unity and knowing the properties of those roots. Second part then relates to, in fact, roots of polynomials and what you know about the sum of the roots. And then the final part is then developing those ideas further in terms of those relationships. On the face of it, not such an easy question, but hopefully we'll show it's not impossible. Okay, so firstly, A part 1. Alright, well, we're interested in the fact that z to the power of 7 is equal to 1, and that one of the possible roots is e to the 2 pi I over 7, which if that's the case, if we put that into the equation, we should end up with a result of showing that it equals 1 when we do it to the power of 7. So we get e to the 2 pi I over 7 to the power of 7, which is going to become e to the 2 pi I, which we should know is equal to 1, but if you don't know, you can rewrite it as cos 2 pi plus I sine 2 pi. And you should know the cos of 2 pi is 1 and the sine of 2 pi is 0, so it equals 1. Okay, so part A, part 1, reasonably straightforward. Then it says write down the 5 other roots, non-real roots. Well, we know that one of the roots would be 1 because 1 to the power of 7 equals 1, but that's a real root. All the other roots, you should know, for the roots of unity, are going to be powers of the root that we are given. So if w is 1 power, then the other roots are going to be powers of that, so it will be w squared, w cubed, w to the 4th, w to the 5th, w to the 6th. Okay, and those are going to be the 5 non-real roots. Okay, so that's part 2 dealt with. You might have written those as e to the 4 pi over 7, 6 pi over 7, 8 pi over 7, and so on. And they would have given you the mark for that as well. Obviously, in the first part we get 1 mark for this, and in this part it's just a method stroke answer mark. Method for showing some idea that you know about the powers, and then an accuracy mark for getting all 5 of them. Part B then says we have to show that 1 plus w squared plus and so on equals 0. Well, what's the equation we're looking at? We've got z to the power of 7 minus 1 equals 0. This is a polynomial of degree 7. So we know that the sum of the roots will be equal to minus b over a. Now, since there is no z to the power of 6, then b is actually 0. So that must mean that the expression will be equal to 0. Well, what are the roots? Well, the first root was 1, the second root was w, the third root was w squared, the fourth root is w cubed, the fifth root is w to the 4, the sixth root is w to the 5, and the seventh root is w to the 6. That's the sum of the roots, so they must add up to 0. So again, by stating that you understand that the sum of the roots must be 0, you'll get 1 mark and then an accuracy mark coming in for getting the sum of all of those roots and showing it clearly. Okay. Now on to part C. Now in part C we're asked to show what's true about w squared plus w to the 5th. Well, what is true? Well, we know that w squared and w to the 5th must equal, well, w squared is the root that we had, which is e to the 2 pi over 7 squared, so that becomes e to the 4 pi I over 7. And w to the 5th is similarly that e to the 2 pi I over 7 to the power of 5, so that becomes e to the 10 pi I over 7. Now the question is, how can we then simplify that? Well, we need to remember that 10 pi I over 7 is going around the circle anti-clockwise. So if we go back clockwise, that would be e to the minus 4 pi I over 7. So this is e to the 4 pi I over 7 plus e to the minus 4 pi I over 7. And this should then look familiar to you, because you need to remember that e to the x plus e to the minus x is equal to twice cos x, yeah, or e to the theta, or whichever letter you use. So e to the x plus e to the minus x is equal to twice cos x. Okay, so that means here that this becomes twice cos 4 pi over 7. So it's this identity that you need to remember. Okay, right, then when we move into part 2, we want something similar for cos 2 pi over 7. Well, if it was w squared plus w to the 5 that created this one, what happens if we do w1 plus w6? Well, that is going to equal e to the 2 pi I over 7 plus e to the 12 pi I over 7, which, similarly to the last one, this e to the 12 pi over I over 7 is the same as e to the minus 2 pi I over 7. So this becomes twice cos 2 pi over 7. Likewise, if we then do w3 plus w4, pairing those together, we're going to get e to the 6 pi I over 7 plus e to the 8 pi I over 7, which again, the e to the 8 pi I over 7 is the same as e to the minus 6 pi I over 7. So this becomes twice cos 6 pi over 7. So we've got three results for w1 plus w6, w plus w to the power of 6, w squared plus w to the power of 5, and w cubed plus w to the power of 4. Well, what was the statement we had in part B? We said that 1 plus w squared, etc. If you remember, let's write it out again. 1 plus w squared plus w cubed plus w to the 4 plus w to the 5 plus w to the 6 was equal to 0. Now what have we got? We've got each of these pairs completed in turn, haven't we? So we can say that this is 1 plus, or the w plus the w to the 6th generates the 2 cos 2 pi over 7. Then the w squared plus the w5 gives you the 2 cos 4 pi over 7. And then the w cubed plus the w to the 4 gives you twice cos 6 pi over 7. And that all equals 0. So how do we get to the result we want? Well, subtract the 1 and divide by 2. And that gives us what we require, that the cos of 2 pi over 7 plus the cos of 4 pi over 7 plus the cos of 6 pi over 7 will equal minus a half. Right, well, where are the marks? Well, in C part 1 we had 3 marks being allocated. So we'll have a method mark for this opening statement, writing w2 squared and w to the power of 5 in terms of e. Then realizing that can then be written in the form e to the 4 pi I over 7 and e to the minus 4 pi over 7, there'll be a mark. And then finally, for getting the correct statement here, we will get 1 mark for recognizing that. Okay. Similarly, in this part, what we'll do, well, if we get this one correct for the w1 plus w to the 6, and recognizing that w to the power of 3 plus w to the power of 4, and simplifying them, 1 for each of those. And then for using the answer in part B to write down a statement which must be true, we'll get a mark. And then for simplifying from there, will give us the final mark. Okay, we've managed to do it. Okay, well, for further help with revision and past paper questions, please go to the Further Maths Support Programme website.